Welcome back to Victory Garage. In the last episode, we brought on Jack and his incredible 3D printing skills, and we started to test our second working prototype of our motor.
So the last motor that we built, it had a lot of missing components, well, electrically, software-wise, and even mechanically.
The next phase after that is to build the first one that is, we'll say, car-sized, meaning it's got sufficient power to drive a car, like the one that's right behind me now.
So we had our eyes on our next big milestone, to build a motor that operates at full power. But to go from a few concept motors to a full power test piece takes a little bit more than just scaling up our design. What we need is stronger materials and more precise manufacturing methods.
So that meant that we had to start working with some more specialized suppliers.
Supply chain issues became clearer sometime in late April. We had a lot of bits and pieces on order to build this motor, and we're being told that we're delay. We thought about how could we resolve this somewhat ourselves. Would a 3D additive manufacturing printer help us? And the answer was yes, if we could spec one that was sufficiently large enough to get the chassis that we want.
My machine was doing the trick, but we were taking it right to and through its limits at times, and I was having to rebuild the head between prints and things like that to keep it moving. And it lasted like that for several weeks, so it was getting to the point where the need for a 3D printer was pretty clear.
Yeah, we were able to transition away from Jack's bedroom, which was a good thing.
I can see it. I can see it.
Yep, that is it.
Holy shit.
Right? That's gorgeous.
So 3D printing opens up a really unique opportunity to make a single, highly unique, highly complex part. And the quality of the print that you need to get for doing an entire motor frame is really high. So in order to get that, it's nice to have a professional type machine and an enclosed volume and a well-controlled, heated environment.
All of a sudden, what was a rendering on a AutoCAD file became physical and colorful and real. And we saw two halves that fit together. We could build a chassis and assemble it and test it, and if we wanted to make some changes to it, we could probably do that within a 12 or 18 hour time frame instead of a couple of weeks of waiting.
So yeah, where are we at now, Isaac? I see Arj throwing in some good sweat, burning some calories over there.
Yep. He's putting the work in to get the tolerances such that we can have the rotor and the stator really close together, but not touching. So in order to do that, you have to have a really flat surface on both sides, so you can get them as close as you can. We've got the cooling system coming together on that. And in here, Jack is assembling the wiring leads between the motor controller and the motor itself. And we're getting everything pretty darn close to spinning.
Manufacturing our own electric motor components sped things up big time. But one of the key elements of our motor still need to be assembled: the electromagnets that make the whole thing work.
So our motor doesn't have permanent magnets. So the magnetic part of the motor that creates a magnetic field comes from electrical steel.
The electromagnets are not made of a single block of steel. They're actually made of a series of laminated pieces of steel. Those pieces of steel are slightly thicker than aluminum foil, or about the thickness of a human hair. And we will take 399 unique pieces of that steel and stack them one on top of the other to make a shape that's about 2 inches tall.
And remind me how many of these we have to manually put together.
399 per stack for 20 stacks, which is 8,379 thereabouts. Nobody can tell you how 399 laminations are going to look when you drop a pile of laminations and have to play 399 pickup. It proves very challenging.
Before our motor could work, All 8,000 of those laminations still had to be put together by hand. It's a painstaking process. But to add to the challenge, we had a deadline coming up that required us to have this motor running flawlessly.
We sought a funding opportunity through National Research Council's IRAP program, and NRC was gracious enough to come in and look at our technology, look at our concept and ideas, and put some funding into it with a timeline. And I think initially, I think the timeline was the end of August or thereabouts. And we were down to the wire, you know, of having this thing operable enough to bring them in and show them. You know, we had a deadline that we'd set for ourselves and that we'd committed to for Monday morning, and it was Friday night, and we weren't ready.
After completing the first lamination stack or two, it was pretty clear that this was actually going to take between 12 and 20 days to complete.
And we needed it over a weekend.
I think that's when we began to set up tables and get dirty with glue and epoxy, and then it was phone calls out to everybody that we could possibly coerce to come in and work.
We very carefully recruited our significant others to join us, which went very well for how it could go.
Isaac and Melissa and Jack and his girlfriend Larissa, they were all there. It was like family.
At the 11th hour, we had a weekend marathon of girlfriends and wives and significant others in here, feeding them pizza and Coke all weekend to build this thing up so that by Monday or Tuesday it was operable enough for NRC to come check it out.
That really taught us. So what the teachings from that process was, we have very supportive girlfriends. And the second was that, you know what, we are all very passionate about this because we were so happy while we were doing it.
It's a very good experience that we'll all remember forever, and we'll all cherish that memory together, so I'm really grateful for that.
The shop is back to looking normal. We got done the final lamination stack, and the first batches of them are curing in the epoxy. So that is going well.
So that weekend's work enabled us to assemble the motor early the following week on Monday. And we weren't ready to run it. We weren't in a place where we could call somebody in and have a look at it running. And I think, you know, as a result of that, we decided to make the tough phone call and say, listen, we think we need a couple more weeks to have this thing in a place where we'd like to show somebody. And we're still not there, and it's still a bit nerve-wracking.
So here's the generation 3 of the motor. So we have the motor fully assembled. The motor is fully on the test bench area here. There was kind of about a 2-week process of us kind of going through and debugging and saying, okay, if we send the signal from here to here, are we getting the right output from that subsystem? Yes. Then you move on to the next one. No, okay. Then you can swap out that part.
When it did move for the first time under its own power, it was a bit of a non-eureka moment.
Recharger on. ABC on.
What were you hoping to hear, and what did you hear instead?
You want me to actually make the noises?
You did so well.
You know, I wanted to walk into the lab and flip a master switch and hear a motor go. You know, and I walked into the lab and they flipped the master switch, and the motor went. So, not back to the drawing board, but oh crap, what did we do? You know, what do we need to do to fix this?
Every single day, there was an expectation, or almost like a suspense that is it gonna work today? And you're just so close to everything working, but you're not sure yet it's gonna work.
Ready?
And you hold your breath the whole time that they've got their finger on the button ready to fire it and turn it on.
ABC on.
And then they pull the trigger, and
Nothing.
you stop and you go, okay, what happened?
Wires burn up and resistors blow and diodes blow,
And you fix that and you go again. You press that button with all that level of excitement that you had the first time.
and then a few hours later, a half a turn, and then a few hours later, a full turn, and then 2 or 3 full turns before something started to smoke.
97 Celsius.
Yep.
Okay.
And that's the stage of electronics debugging in particular that's really challenging.
Why is that not working?
And I think every day the anticipation and the anxiety related to that just kept growing more and more.
When we started debugging this process, we started with a list, quite significant. And by the end of the time that we were debugging this, we had come down to our last couple of items on the list that we were checking. At this stage, you are now up at the point where you've exhausted your understanding of the system, and you have probably checked everything that you can check twice. We were coming up on 7:30 at the end of a Friday at this point, and we were finally at the end of our list and ready to throw the switch for probably the last time.
What are your thoughts on this test?
I'm pumped. That was gonna work.
I was like, yeah, I've heard that before. In my head, that's what I said.
Recharger on.
Yeah,
There we go.
The moment he said ABC on, he pressed that button. And he couldn't even see what happened.
ABC on.
Whoa! Look at that, guys. What?
Yeah!
Yo, that is awesome.
All I did was yell. I was just yelling. On the video, you can hear it. It's like, that's the closest thing that I can say when I was an adult to feeling like a child.
It was, I can't even describe it. It was just an amazing experience to get to see the former fancy rotor sitting on bearings actually become a motor.
Oh my God, man, it works.
So we're holding, by the way, we're holding at 60 RPM. By the way, that's
wow.
like, you can kind of hear that weird noise. That's the rev limiter.
The feeling that happened when that motor spun was...
Mr. Barkhouse, how do you feel?
Everything is working exactly as I wanted to.
It sent me right back to the moment when Steve and I had the initial conversation where he just said, "Well, can you build a motor?" And I said, "Yes, I can." And every day that it takes that motor isn't spinning is another day where the pressure's building. It's always weighing on you that, this really needs to work.
Yeah, we're 6 months into this now, and it's a huge investment. The clock's ticking, the meter's running. There's a lot of costs to do this on a monthly basis.
We're banking a lot on this motor working as I said it would.
When you've put as much time and effort and love and passion as we have over the past couple of months into this motor build, and to finally see it do the thing that you promised it would do, it's like someone cut the sandbags.
I would say that the term would be weightless. It felt like that. It felt so relieving and de-stressing in that moment.
All of this pressure kind of being relieved kind of from my shoulders, and I probably was standing up, a few centimeters taller.
Finally, whatever we've worked for to achieve, that came true.
I think the fact that they hit this thing with juice and it spins, it was huge validation for all of their science and all of their engineering and all of their work, and I'm tremendously proud of them.
Spinning up a full-size, full-power motor was a huge accomplishment for the whole team. But Steve thought to himself, maybe these guys need a bigger, a hairier goal to strive for. And that's when he started scheming.
I kept feeling my phone buzz in my pocket.
I see this post of, what do you guys think of this vehicle?
The response was, "Oh, that's an awesome car. Wouldn't that be cool? I'd love to have that car. That's really great."
When I got home, effectively the text message was, "Well, that's great because we bought it."
So we just bought it, and by the way, you've got 8 weeks to get a motor in it and get it out on the street. So I'm not sure I was popular that day or not.
For the first thought was, oh, this thing is going to be awesome. And then my second thought was, oh, this is also going to be a lot of work.
I was like, Steve's really crazy. This is not possible. That's what my thoughts was initially.
Yeah. So this thing is a lot of fun. It's a Baja Beetle, and we're going to make it electric.
All this on the next season of Victory Garage.